Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my channel. In continuation of power system protection series, today we are going part 2 of this series. In this part, we shall discuss faults and abnormal operating conditions. Following topics will be covered briefly in this session. Uh, we will see shunt faults, causing and effects of the shunt faults, classification of shunt faults, series faults, abnormal operating conditions. First of all, we shall discuss faults and then abnormal condition. In power system, fault is condition that involves the electrical failure of the equipment like transformer, motor, etc. Shunt faults. When the path of the load current is cut short because of a breakdown of insulation, we say that a short circuit has occurred. When the path of the load current is cut short because of breakdown of insulation, we say that a short circuit has occurred. A short circuit is a fault in which a live wire touches a neutral or a ground wire. Shunt faults or the short circuit faults are basically due to the failure of insulation. Now, insulation may fail because of its own weakening or it may fail due to overvoltage. The reason of the weakening of insulation is due to aging, temperature, rain, chemical pollution, foreign objects, and the overvoltage may be due to the internal switching or external switching. Effect of the shunt faults: if the power system is isolated alternator feeding their own loads, then the fault current would not be much of the concern. In case we have an interconnected power system, faults cause heavy currents to flow. If these currents persist even for a short time, they will cause extensive damage to the equipment. Shunt faults has much impact on power system stability and on generators. Interconnected system generator must operate in synchronism at all the instants. The electrical power output from an alternator near the fault drops sharply. This causes the alternate to accelerate, alternate starts swinging, and the alternate will have to trip out. So, in an interconnected system, the system stability is at stake if the swing is out of control. Now we see the classification of the shunt faults. Those faults which involve only one of the one phase and ground are called as a ground fault, while the faults involving two or more phase conductors with or without ground are called as a phase fault. Power systems have been in operation for over 100 of years, so experience shows that all the faults are not equally likely. Single line to ground faults are the most, whereas the faults due to the all three lines, that is three phase fault, is the least likely. You can see the fault and the probability of the occurrence of the fault in the given table. Now we will discuss series fault. Open circuit faults are called as a series fault. Series faults are nothing but a break in the path of a current. Suppose we are using a circuit breaker or a fuse to protect the circuit. If one or two phase open and the third is still in the circuit, such kind of a fault is series fault. Now we will discuss the abnormal operating condition. The boundary between the normal and the faulty condition is not a crisp. Certain operating condition inherent to the operation of the power system, which are definitely not the normal, but these are not the electrical faults. For example, starting of the induction motor, inrush current of the transformer, condition of the power system during power swing. These are the abnormal operating condition. Magnitude-wise, these currents may qualify as a fault, but there is no need to provide protection from them. Therefore, the protection system must be able to distinguish between a normal, abnormal condition and the faults. So that's all from today's session. In the next session, we will see protection system and its attributes. We shall discuss about current transformer, PTs, relays, circuit breaker, etc. So keep watching my channel. Thanks for watching. If you like this video, then please share, like, and press the bell icon for more informative videos.